Welcome to my YouTube channel, Mr. Rafa Online Tuitions. Have you subscribed to the YouTube channel? If not, do me a favor, subscribe to the YouTube channel, Mr. Rafa Online Tuitions, for more videos. So in this session today, we are going to look at the principle of moments. In the previous video, we did the first part of moments. So we are here today. We want to look at the principle of moments. So we are cracking the codes of physics. We are unveiling the secrets of physics. So part 2A states the principle of a moment. So principle of a moment, it says that if a body is in equilibrium, then the sum of the clockwise moments is equal to the sum of the anticlockwise moments about a point called a pivot. So the principle of a moment, it states that if a body is in equilibrium, then the sum of anticlockwise moments is equal to the sum of clockwise moments about a pivot. About a pivot. Principle of a moment, it says that if a body is in equilibrium, then the sum of the anticlockwise moments is equal to sum of the clockwise moments about a point which is called a pivot. So when we look at equilibrium, what does it mean? Equilibrium, in other words, it means when a body is at rest or a body is balanced or a body is moving at a constant speed. Moving at a constant speed. The body is moving at a constant speed, then it is in equilibrium. When the body is at rest, then it is in equilibrium. When the body is balanced, then it is in equilibrium. So, if a body is in equilibrium, if a body is balanced, if a body is at rest, if a body is moving at a constant speed, then the sum of the anticlockwise moments is equal to sum of the anticlockwise moments. So mathematically, the principle of a moment, it can be expressed by saying the anticlockwise moment is equal to the clockwise moment. So this is the formula for a moment. So let's say this is the anticlockwise moment. This is the clockwise moment. So the anticlockwise moment is equal to the clockwise moment if the body is in equilibrium or if the body is balanced, if the body is at rest, if the body is moving at a constant speed, then the anticlockwise moments is equal to the anticlockwise moments. Don't forget to subscribe to my YouTube channel, Mr. Rafa Online Tuitions. So like the video, the comments. Are you enjoying what I'm doing? Comment in the comment section. I need your comment. I need your feedback. Part B. Describe an experiment to determine the principle of a moment. So remember that science paper 1, it has 3 sections, section A, section B, and section C. So mostly the questions that come for section C, they are what we call experimental questions, such as that one. So mostly the questions that come, they are experimental questions, such as that one. So describe an experiment to determine the principle of a moment. So I'll try to explain to you. Okay, so how do you describe an experiment to determine the principle of a moment? So number, you can be given the masses. Maybe mass number 1, it has 100 grams. Mass number 2, it has 50 grams. Mass piece number 3, maybe it has 10 grams. So the first thing, what you have to do when you want to determine an experiment of a moment, of the principle of a moment, you need to calculate these mass pieces to weight, or you convert them to weight. So how do you convert these mass pieces to weight? So it's by using this formula mass. It's by using this formula weight. It is by using this formula weight is equal to mass times gravity. That is the first thing. So the first thing, you need to convert the mass pieces to weight. So you convert mass pieces to weight by using this formula. So each mass piece, you convert it to force or to weight by using this formula. Then the second thing, you need to set up an apparatus. This is a meter rule. This is a meter rule. It's a ruler. So this meter rule, you have to balance it on a pivot. You can use the edge of the knife as your pivot. You can use a test tube as a pivot. So this is a pivot. So you balance your meter ruler on a pivot at 50 centimeters mark. So that is the first thing, you balance the meter ruler. Then the second thing, you are going to take a mass piece. For example, you take this mass piece. Okay, you get this mass piece, which is 100 grams. You place it on the left side of the pivot. You place it here, 100 grams, you place it here. Then you take another different mass piece, for example 50, you put it here. Okay, so you place it on the right side of the pivot. Then the next thing, you begin to adjust this mass piece. You begin to adjust it. You put it there, you put it there, you put it there, until this lever is balanced, until it is balanced. So for example, it balances itself at this position. From there now, you are going to record the distance from the center of the mass piece to the pivot. You record this distance as distance 1. You record this weight as force 1. Okay? Then you also measure and record the distance this side from the center of the mass piece to what? to the pivot. You record this as distance 2. You record this mass piece as force 2 or weight 2. So the force and its distance. The force and its distance. So now, mathematically, we can verify the principle of a moment by saying this is anticlockwise. This side it is anticlockwise, okay, because it is moving against the hands of a clock. So this is anticlockwise. It is going this side. So clockwise, it is this side. So it is going towards the ends of the clock. So this is clockwise, this is anticlockwise. So now, if this is balanced, then the anticlockwise moment is equal to the clockwise moment. So mathematically, it can be expressed by saying anticlockwise moment is equal to anticlockwise moment. Then you can repeat the experiment using different mass pieces at different distances. So that's how we can determine the principle of a moment. Type an experiment to determine the principle of a moment. So the first thing, as we said, you calculate. The first thing, calculate or measure each mass piece by using the formula weight is equal to mass times gravity. So calculate or measure each mass piece. Number 2, you need to set up the apparatus. So in this case, we are going to even show the diagram. Okay, so set up the apparatus as shown, because we need to draw the diagram. So set up the apparatus as shown, because we are going to set up the diagram as well. So set up the apparatus as shown below and ensure that the meter rule is balanced. At 50 centimeter mark. Then number 3, place one mass piece on the left side of the pivot, okay, and place another different mass piece on the right of the pivot. Then the next thing, adjust the mass piece on the right until it is balanced. So when it is balanced, you record the word of each mass piece and its distance. Okay. So now don't forget to put up the diagram. Don't forget to put up the diagram. Don't forget to put up the diagram. So this is the meter rule. This is the pivot. Okay. So at 50 centimeters mark. So this is a pivot. So you draw and label. This is a meter rule. Okay. So this is mass piece number 1. So which is F1. So the distance, it is from the center of the mass piece to the pivot. So this one has distance 1. So you record, and this is mass piece 2. So you record its distance from the pivot to the center of the force. So you record it as distance 2. So mathematically, it can be expressed as anti-clockwise moment is equal to clockwise moment. So that is how we can determine the principle of a moment. So the first thing, you measure or calculate each mass piece by using this formula. So number 2, you set up the apparatus. You set up the apparatus as this one, okay? You ensure that the meter rule is balanced at 50 centimeter mark. Then you place one mass piece, you place one mass piece on the left side of the pivot, this one, okay? And you place another different mass piece on the right of the pivot. So now you begin to adjust this one. You adjust the mass piece on the right until the lever is balanced. So after it is balanced, you record the weight. So like if we use this 100 grams, so 100 grams is 1 Newton. So you record 1 Newton and its distance, okay, from the center of mass piece to the pivot, you record its distance. You come this side, if this is 50 grams, then it is 0.5 newtons. So you record also its distance. Then mathematically, you verify by using the principle of a moment. Hope you are enjoying, ladies and gentlemen. These things, they are nice. These things, they are nice. Mwema kombea mfumu ififintu ififisuma sana fyali nakanga chako bati twabombera chapamu mukwai konsoko mulengo mfuira. Don't forget to subscribe to my YouTube channel, Mr. Rafa Online Tuitions. Facebook page, don't forget to like it, Mr. Rafa Online Tuitions. Please, I need your feedback. Don't forget to comment. I want to hear your feedback. Are you enjoying? I want to hear your feedback. Okay. Part C. What are the 2 factors that affect a moment? So a moment can be affected. Number 1, a moment can be affected by the magnitude of a force. So what does it mean? It means that when you change the size of a force, moment also it will change. When you increase the size of a force, moment will change. So it is a factor. So force is a factor. When you change its size, moment will change. So magnitude, it means size. So the size of a force, it matters. So when you change the size of a force, you reduce it, moment will be affected. It will change as well. When you increase the size of a force, moment will change. So the magnitude or the size of a force is a factor. The other factor, it is simply the distance of the line of action of force from the pivot. That's the second one, the distance of the line of action of the force. From where? From the pivot or from the center of rotation. Wonderful. Wonderful, wonderful. So these things are nice. These things are nice. These things are nice. Wonderful. We proceed as we continue to crack the codes of physics. As we continue to crack the codes of physics. We continue as we continue to crack the codes of physics. We continue as we continue to crack the codes of physics, to unveil the secrets of physics. Calculate force W. So now, this is a balanced lever. It is a balanced lever. We have two forces. We have a pivot. So this is a pivot. So this is anti-clockwise. This is a clockwise. This is a pivot. So we have this weight, 24 newtons. Its distance from the center of this weight to the pivot is 0.8 meters. Then we have weight W. So its distance from the center of this weight to the pivot is 4.0 meters. So calculate W. So for us to calculate the value of W, we are going to use the principle of a moment. So remember, mathematically, a principle of a moment is determined by F1 times D1 is equal to F2 times D2. So force 1, we have 24. So this is force 1, distance 1, force 2, distance 2. So force 1, it is 24 newtons times 0.8. Force 2, we have W times distance 2, it is 4. So simple mathematics. So 24 times 0.8, just use a calculator there, you're going to have 19.2. So 4 times W, it is 4W. So you divide both sides with 4. 4 goes, you remain with W. So W is 4 into 19.2 is 4.8 newtons. So make sure that N is in the capital letters. It's a name of a person, Sir Isaac Newton, so it must be a capital letter. Wonderful, wonderful, wonderful. These things are nice. These things are simple. Follow me as we crack the codes of physics. We unveil the secrets of physics. Don't forget to subscribe to my YouTube channel, Mr. Alpha Online Tuitions. Please, I want to hear the feedback. The feedback. Are you enjoying? Are you enjoying? Can you comment? Can you comment? Are you enjoying? Okay, so we go to the other part. Very important. Very important. We proceed. Calculate distance x if the lever is balanced. If the lever is balanced. So we have this lever, it is balanced. The lever is balanced. So in this case, we have the anti-clockwise and the clockwise. This is the pivot, anti-clockwise, clockwise. So the distance from the center of this mass to the pivot, it is x. So from the center of this mass to the pivot is 20. So here we have force 1, we have force 2, we have distance 1, we have distance 2. So now we are going to use mathematical expression of the principle of a moment since the lever is balanced. So we are going to say force 1 times distance 1 is equal to force 2 times distance 2. So force 1, it is 25. So what do we want? X. Calculate distance x. So distance x equals F2, it is 8 newtons times distance 2, it is 20 meters. This is 8 newtons. This is 25 newtons. So distance 2, it is 20. So in this case, I'll multiply 25 times x, it is 25x, 8 newtons times 20 meters. I'm going to have 160. So 160. So this is 25x. Then I'll divide throughout with 25. Throughout with 25. 25 into 25, that's 25 into 160. So there you just use a calculator. We're going to have 60.4 meters. That is the answer. Wonderful. These things are nice. Don't forget to like the video. Like the video. Don't forget to comment. You comment. Okay. Number 4. Number 4. Calculate force F if the lever is balanced. Calculate force F if the lever is balanced. So, to the anti-clockwise, which is the left side, we have two forces. Okay? We have two forces. We have 4.6 newtons. We have 2.4 newtons. Okay, so and then we have the distance of 4.6 newtons is 50 centimeters to where the second force is. Okay, not to the pivot, 50 centimeters to where the force 2 is. Then from force 2 to the pivot, it is 10 centimeters. Then we want the value of F. So let me say this is force 1, force 2, force 3. So now, distance 2, it's the distance from this force to the pivot. So it is 10 centimeters. Okay? Now, the distance from force 1 to the pivot, it is not 50 centimeters. Remember that when we are getting a distance, it is from the center of the force to the pivot. So you add 50 plus 10. So distance 1, it is going to be 60 centimeters and not 50. Then for C3, we have 40 centimeters. Don't forget to convert the units from centimeters to meters. Don't forget to convert. So in this case, mathematically, this means force 1 times distance 1 plus force 2 times distance 2 is equal to force 3 times distance 3. So force 1, that is 4.6 newtons times distance 1, which is 60 centimeters. So 60 centimeters, it must be converted to meters. How do you convert from centimeters to meters? You divide by 100. So why am I dividing by 100? I'm converting from centimeters to meters. Plus force 2, that is 2.4 times distance 2. From here to the pivot, it is 10 centimeters. So it will be 10 over 100. I'll repeat again. Why am I dividing by 100? I am converting from centimeters to meters. Is equal to 43 times 40 centimeters divided by 100 centimeters. So we are converting to meters. Okay, so 4.6 times 60 divided by 100. I'm going to have 0.6 plus 2.4 times 10 divided by 100. It is 0.1. F3, 40 divided by 100, it is 0.4. So now we multiply 4.6 times 0.6. I'm going to have 2.76 plus 2.4 times 0.1. The answer is 0.24 equals 0.4 F3. So now 2.76 plus 0.24. So there we are going to have 3 equals 0.4 F3. So you divide throughout with 0.4, 0.4. So there 0.4, 0.4 goes. So F3 is equal to 3 divided by 0.4. The answer is 7.5. Don't forget units. So 7.5 newtons. Don't forget the units. So the answer is going to be 7.5 newtons. Thanks to follow my Facebook page, Mr. Rafa Online Tuitions. I need your feedback. Comment, like the video, share the video. Don't forget to share the video. Share to your friends. Share to your friends. So in the next video, we'll be answering this question. We'll be answering this question. We'll be answering this question. In the next video, I'll be answering this question. Very important. In the next